In this video we're going to look at manipulating a function of one variable on the 2D plane. So the function we have at the moment is f of x is equal to x cubed, so we can change this to any function. So let's change it to x squared. We can rotate it around a point, 360 degrees. We can adjust the y crossover. We can adjust the amplitude of the function. And we can adjust the position along the x-axis. So that allows us to adjust the function in the 2D plane. Now we could use a different function, for example Sine X, and you can see here, if we set everything back to the initial position, we can adjust the rotation, the crossover, the amplitude, and the phase. So that's us able to adjust a one-dimensional function on the 2D plane. Now let's look at how we do this. We have our equation that we want to manipulate. In order to rotate it, we use the simple rotation matrix. The input for the rotation matrix is the x and the y-axis, and also the rotation angle θ1. We adjust it so that the rotation angle that we put in is actually in degrees rather than radians. And then we take the output. Now the output is just the value y0, which is just going to be a position here relative to the x-axis. So y0 is going to equal the output f of x0. x0 is just the x input. And then we can adjust the amplitude of the output here by multiplying by a underscore amplitude. We can adjust the phase of the output by adding on p underscore phase here within the brackets. And we can adjust the crossover point here by adding on plus crossover. And these are the values here. We have our rotation, we have our crossover, we have our amplitude, and we have our phase. So this is quite handy, and it shows us that we're able to manipulate any function in any way on this 2D plane.